Okay, so let's look at this first example of related rates word problem. So assume that x and y are differentiable functions of t. So if y equals 3x squared minus 5x, we want to find dy dt whenever x equals 3, given that dx equals 2. So for this one, the first thing we need to do, so if we know our function y equals 3x squared minus 5x, then we first want to implicitly differentiate this. So we're assuming that x and y are both functions in terms of t. So that means we need to first implicitly differentiate this. So remember, the derivative of y with respect to t is going to be dy dt. So dy dt equals the derivative of 3x squared with respect to t. So that's going to be 6x times dx dt. And then minus the derivative of 5x with respect to t. That's going to be 5 dx dt. All right, so now let's just clean this up a little bit. So dy dt is equal to the quantity 6x minus 5 times dx dt. So all I did there was factor out my dx dt. So we're going to need this for this one and also for the next one, part B. So for the first one, part A, so we want to know dy dt whenever x is 3, given that dx dt is 2. So we know our function dy dt is equal to 6x minus 5 dx dt. So now we just substitute in all of our knowns. You'll always have enough information to find all of the knowns except for one thing, that you can only ever have one unknown with one equation. Now, if you have enough information for two different equations, then yes, you can figure out a way to eliminate one of the unknowns. And so you could have more than one unknown potentially at the beginning, but you'll always have enough information to find everything except for one unknown that you'll end up solving for at the very end. But in this case, we have everything except for dy dt. So let's just substitute in. So dy dt. So we were given x equals 3, or we want it when x equals 3. So that's 6 times 3 minus 5. Times dx dt we're given was 2. So then dy dt in this case, we just multiply this out. So 6 times 3 is 18, minus 5 is 13. So 13 times 2. So dy dt in this case ends up being 26. So for part B now, we want to find dx dt whenever x is 3, given that dy dt is 4. So again, the same idea. So now we know our equation already, so we don't have to find it again because it's the same f function. So dy dt is still equal to 6x minus 5 dx dt. So the exact same process, except now we have our dy dt. So we sub in. So dy dt is 4. 6 times x is 3. Minus 5, all of that times dx dt, which in this case we don't know. So we have 4 is equal to 13 dx dt. So then that means that dx dt, dividing by 13 on both sides, is equal to 4/13. Alright, so for the second part of example 1, so we're still assuming x and y are differentiable functions of t. So now, though, we have the equation x squared plus y squared equals 25, and we still want to find dy dt now whenever x is 3, y is 4, dx dt is 8. So the first thing we want to do now is find out our implicit derivatives. So start out with our equation x squared plus y squared equals 25. Implicitly differentiate this entire thing with respect to time. So derivative of x squared is 2x dx dt, because we're differentiating with respect to time, plus the derivative of y squared is 2y times dy dt, equals the derivative of 25 now is 0. Why? That's right, because 0 is a constant. So we have our equation that we're going to use for parts A and B here. So 2x dx dt plus 2y dy dt equals 0. So now, where do we go from here? So we use that equation just like before. So 2x dx dt plus 2y dy dt equals 0. And now substitute everything we know. So we know in this first one, x is 3. So 2 times 3 times dx dt is 8. Plus 2 times y, we're told, is 4. Times dy dt, are unknown in this case, equals 0. So 2 times 3 times 8, we get 48. 4 times 2 is 8, so 48 plus 8 dy dt equals 0. So subtract 48 from both sides, so 8 dy dt is equal to negative 48. And now divide by 8 on both sides. We end up with dy dt equals negative 6. All right, so part B now, let's find dx dt whenever x equals 4, y equals 3, and dy dt is negative 2. So let's use the equation we already found. So 2x dx dt plus 2y dy dt equals 0. So now 2 times x, we're told, is 4. We don't know dx dt. 2y, we're told, is 3. And dy dt is negative 2 equals 0. So we have 8 dx dt minus 12 equals 0. So add 12 to both sides. 8 dx dt equals 12. So dx dt is equal to 12/8, which simplifies. So we get dx dt equal to 3/2.